Welcome back. We are on day 10 for preparation for Canadian Open Mathematical Challenge. So let us see what problem we have here today. The cubic equation shown has three positive integer roots. Determine the value of p. We have x cubed minus 10x square plus px minus 30 equal to 0. It has three positive integer roots. So the question is, we need to find out what the value of p is. Take 5 minutes to solve this question on your own, and once you solve it, please come back and check your solution here. Thank you. So let us jump ahead and try to solve this problem. So what do we have here? So we have this equation x cubed minus 10x square plus px minus 30 equal to 0. So the question says that it has three positive integer roots, and let us assume that these roots are p1, p2 and p3. So if a cubic equation has three roots p1, p2, p3, we can write that cubic equation as x minus p1 times x minus p2 times x minus p3 equal to 0. So we have x minus p1 and x minus p2. Let us multiply x minus p1 with x and then multiply x minus p1 with p2. So we are multiplying x minus p1 and x minus p2. So what it looks like. So the first term, x times x square minus p1 times x minus p1x. So we multiplied x minus p1 with the first term, which is x, and next we will multiply x minus p1 with the next term minus p2. So x times minus p2 is minus p2x, and minus p1 times minus p2 will be equal to p1 p2. So the product of x minus p1 and x minus p2 is x square minus p1x minus p2x plus p1 p2. In the next step, we multiply this entire whole x squared expression with x minus p3. So let us see what it looks like. So as we did before, we take this entire expression on the left and multiply with x in the next expression. So it becomes x cubed, next will become p1x square, next will become p2x square, the last will become p1 p2x. And now we are left with multiplying minus p3. Minus p3x square plus p1 p2x and plus p2 p3x. In the last term, p1 p2 p3 times minus will be equal to minus p1 p2 p3 equal to 0. If we rearrange all the terms, like all the x squared terms in one place, all the x terms in one place, and all the 0th power terms in one place, the next part of the equation looks like this. It becomes x cubed minus of p1 plus p2 plus p3x square plus p1 p2 plus p1 p3 plus p3 p2x minus of p1 p2 p3 equal to 0. So as per our question, so this expression is exactly same as the expression below. Since the quotient of the first term of x cubed are 1 and 1 in both the equations, all the other quotients should be equal to each other. If I take the constant in the expression here and compare that with constant in the expression that is given to us, both of them should be the same. Meaning p1, p2, p3 should be equal to 30. So the condition in the question was there are three roots, right? And all three of them are integers. So this product 30 should be able to be written in product of three integers. So since 2 multiplies 30, we can write 30 as 2 times 15. And 15 we write it as 2 times 3 times 5. So our question says that it has 3 positive integers. So 30 should be written as a product of 3 positive integers. There are only 3 integers that satisfy this condition. We cannot find any other integers when we multiply them whose product will give us 30. So the roots of the equation are 2, 3 and 5. Now the question is, what is P? So P here is a quotient of X, and the quotient of X here is P1, P2, P2, P3 and P1, P3. So P here equal to sum of P1, P2, P2, P3 and P1, P3. So here let us assume that P1 is 2, P2 is 3, P3 is 5. So it becomes 2 times 3 plus 3 times 5 plus 5 times 2. So finally P equals to 31. So the conclusion of this problem is, if this expression has 3 positive integer roots, the positive integer root should be 2, 3 or 5. And since the roots are 2, 3 or 5, the term P here, the quotient P here should be equal to P1, P2, P2, P3, P3 and P2, which becomes 31. So this is a combination of factorization and algebra. Hope you have enjoyed this question, and for more content like this, please subscribe to my channel. Thank you.